Hi everyone, thanks for watching my YouTube content. I'm Tom Kim. In the previous video, I showed you how to get information such as variables and observations related to principal component analysis. These informations such as contribution, cosine, and coordinates are very useful to understand the output of principal component analysis. I think visualization is more intuitive and practical to clearly understand the relationship among observations and also variables, and even observations and variables. Having said that, I would like to show you how to visualize the output of principal component analysis using R, and explain the meaning of visualized outputs. So it's a quick summary. So in the previous video, I showed you how to do principal component analysis by using PRConf function or printconf function. And you need to specify scale as true in order to standardize your raw data. Then we can get these principal component outputs. So the first principal component represents the overall body size, and second principal component shows the comparison between height and width, right? So these three height variables has negative principal component, and with three width variables have positive principal components. So So I showed you how to get these principal component scores for each observations by using eigenvalues and eigenvectors. Right. Then once you get principal component output, you can draw this principal component analysis by plot by using by plot function, right? So let's see to understand observations meaning, the meaning of the location of each observation. Then let's get the first ID here. So this standardized value for first ID. So as you can see, first ID, let me show you this one anyway, is 37 here. So as you can see, first observation has shows this line. So we need to focus. We need to think of the angle of the this observation and variable. Then it's almost 90 degrees. As you can see, it means that there is no like a strong relationship between them. However, for height standpoint, first observation has negative relationship with height. So as you can see, that's why standardized value for height related to for first ID has a negative standardized value. However, if you focus on this number, 37 observations, then it has positive relationship with width and also positive relationship with height, right? That's why it has positive values. And now, and next, I want to show you. I want to compare these two, 37 and 27. So we can expect these two observations have positive standardized value. However, this 27th observation, this one, is actually has further distance compared to this one. So that's why it has a little bit larger number than this one in terms of width, right? This one. So if standardized value is relatively large, then it will be located outside of this two-dimension plot. However, if it is very close to average, then it will be located in the middle of this graph. However, I think when you interpret principal component analysis output, you need to more focus on the angle of these two. right? And also, if you use GG45 library, then you also can have this autoplot output. This is actually to compare sex, first sex and second sex. So as you can see, for first principal component, the blue points, blue observations actually shows lower, smaller principal component scores compared to first sex group, right? So this is actually a male group and this is a female group, right? The third one. There is also a very practical library, Factor Extra here. So you can draw this kind of principal component analysis with colored outputs. So if there is, it shows a higher contribution, then it will be located outside of the graph. But if contribution is relatively low, then it will be located in the middle of the graph. And the last one, this one, actually I draw this graph based on cosine. Then we can see also this kind of graph. So if it has a higher cosine, that it will be located in the outside of the graph. Okay, if cosine is relatively small, then it will be located in the middle of the graph. The last visualization is same as actually first one. Okay. Same output, but also this factor extra and FV's PCA biplot function is more practical. You can modify color and also size of font. So this one, 67.1% is actually contribution of total variance, and this one is a second principal component contribution. So if you sum up these two, then actually among total variance, first two dimension explains 92.2% of total variance. So it has, we can say that these two dimensions are enough to explain the relationship between observation and variable, and also observation and variable. So again, if you visualize principal component analysis by using biplot function, you can quickly and easily understand the relationship between them. I hope this video is useful to understand how to use visualized output to understand principal component analysis. Thank you.